I'm Derek Bolser. Let's see, I graduated from UT Austin, with my PhD in 2021, which was in marine science. And these days, I work for NOAA Fisheries, where I'm the National Fishery Independent Survey Science Coordinator, which is a long title that basically means that for all of our standardized field data collections that we use to monitor marine populations of fish and other organisms, I try to basically improve those, try to make them better. Sometimes that's by helping groups collaborate and coordinate. Sometimes it's by thinking about where it makes sense to apply a new technology and or estimation method. And other times it just means taking a look at what we do from a bird's eye view and thinking about, should we do it this way or is there a better way, just generally. The first job out of the PhD, which was like 2 days later, was a postdoc with Oregon State University and the NOAA Northwest Fisheries Science Center. Um, there, I was, see if I can explain this in a not jargony way. I was basically trying to predict the age composition of a fish across the US West Coast. And I was doing that to develop biomass at age estimates for this fish, using another complementary data stream, because that's what's used as a primary input to something we call stock assessments. And stock assessments are essentially just mathematical models that integrate a bunch of different types of data to make a forecast of how the population is doing, and how they're going to do in the near future, so that fishery managers can make catch advice. So, as maybe you can tell, that was really applied and fairly pertinent to what I'm doing now. And that was what attracted me to it. I mean, I got into this field because I like fishing. I'm interested in basically knowing where the fish are, how many of them um, are in any particular location, and if I can catch them. And this is kind of allowing me to work on those questions at a really large scale. So that was, the reason on the face of it. Also, so this was 2021, still in COVID. I had the opportunity to do that remotely, which was really great because my wife is also a marine scientist. I met her at UT. We were in the same grad program, and she had the opportunity to do a postdoc in Vancouver, Canada. So actually, while I was working for Oregon State, with people in Oregon and, with people at the Northwest Center, mainly who were in Seattle and other places in Oregon, I was actually living in Vancouver. So I could support my wife there. We didn't have to spend a long time apart from one another, which unfortunately sometimes is the case when you have sort of two academic people in the relationship. I think to understand my progression is to understand like that, me and my wife were both pursuing jobs in research, which can be challenging. And so a lot of my story is really our story. And the best advice we got there was from somebody at UT, Posan Ku, who's a career counselor in the College of Natural Sciences. And we sort of came to Posan, we were like, well, okay, maybe once we get to the permanent job stage, at a lot of academic institutions, there might be opportunities for like a spousal hire, and other sort of dual career considerations. But at the postdoc stage, there's not really a lot of that. So we came to Posan and we said, what do we do? his advice was to have, one person do their ideal thing, even if it means that the other person um, has to take, a year off or a year or two off or something like that, write papers, plug in wherever. Um, and then, after that, you can see where that takes you. Perhaps you would switch off, and now the person who was kind of taking their time off pursues their ideal situation. That is preferable to having, two people do two mediocre things. So, in a sentence, he said basically somebody needs to be doing their ideal thing, because that sort of opens the door to the next thing. And taking a little time where you're less productive but be wrapping things up, which is sort of a foreign concept, I think, to many of us. That's okay as long as somebody's doing their ideal thing in the relationship. So, I don't know if that's how generalizable that advice is. I mean, it's a very specific situation, but that was definitely the best advice that I got, that my wife and I both got. Um, Led to me taking this remote postdoc, which actually ended up aligning pretty well with um, what I ended up doing, and yeah, led to sort of the situation we're in now, which is a happy one. So, as an organization, we at NOAA Fisheries, especially in this field that I'm in, which is these long-term, sustained, standardized data collections, it's very difficult to tell what's more important, which one is more important than another one, which one you should do, in one year versus another year, and then which ones, say, if a ship breaks down and you have to do half of one and maybe none of another, like how do you make those decisions? There's no real good way to do that. And so one of the things that is super interesting that I'm working on is trying to develop sort of science-based advice for making those decisions. So some of it is based on what we call the life history traits of organisms. So these are like how fast they grow, how much they reproduce, things like that. That can tell us about sort of the stability and productivity of the population that we're trying to measure. So if you combine that with knowledge of how your sampling affects what we call uncertainty around your management quantity, so usually like a biomass estimate, you can kind of sketch out a relationship or calculate a relationship between sort of number of sampling stations and how effectively confident you are in your projection of how that population is doing. So you can kind of use like the innate productivity and then maybe some characteristics of the ecosystem combined with what do you actually get when you're going to sample, and start to develop a framework, kind of like a decision support tool for making those tough decisions at, it might be annual planning cycles. It might be, oh no, the ship just broke down. What do we do? So that's something that's ongoing. It's being developed, but it's super interesting. And then relating to like what sort of skills for my PhD are contributing to that, I was really lucky to get exposed to quite a lot of different types of analyses and domains, and really everything from basic fish biology, all the way up to spatiotemporal statistical modeling at large scales. So tackling these problems kind of required a broad base of knowledge, and I sort of walked in the door and was, oh, I know something about fish biology. Oh, I know something about that sort of analytical method too. And so it's been really cool to have an opportunity to pull together a lot of this stuff that I learned, in my degree to solve real problems that we have as a government agency, as well as just to connect the dots between stuff I didn't think was super related at the time, just things I was doing because it was interesting or because my advisor asked me to. It's kind of all been useful, which has been great. A typical day. So, I mean, of course, there's lots of emails. I think that's kind of unavoidable. But the interesting stuff is like, you know, in a good day, I'll have a little time to noodle on things like that, like the analysis I just described. Um, things that I'm sort of leading myself. But another fun part is I get a chance to interact with lots of people at our regional science centers and help them out with projects and things like that. So in any given day, I might have an hour or two of time to myself to work on various things that I'm trying to push forward. I might have a meeting or two with somebody at a science center to talk about some work that they're doing, and then I might uh, have like a working group meeting. In the government, we love working groups and committees and stuff, and so there's a committee and a working group for just about anything under the sun, for better or for worse. And I'm on a few interesting ones and a few that are sort of less interesting. But a typical day might be sort of one of both. So, you know, a fair amount of virtual meetings, but also some interesting focused time to, do some sciencey type stuff as well as talk science with some interesting people in the regions. Most of the data that I analyzed in my PhD, I collected alongside commercial fishermen in the Gulf of Mexico. We all worked on a project where we go out to oil rigs and we would do hydroacoustic surveys. So think of it like sonar or even like echolocation, like a dolphin would use. You have an instrument that pulses an acoustic beam through the water, and then the transducer then records the results. And with that, you can enumerate the fish all throughout the platform. So we were doing that, driving circles around oil rigs, dropping cameras to see what kind of fish we were sampling, and doing a little fishing too. And so I would be working on the boat with the research team as well as the fishermen that were helping us with the project. So that was some really useful experience, and the tools that I used, in addition to just being at sea, which was useful, but the tools that I was using ended up being a lot of the same tools that are used in the surveys that I deal with now. That the hydroacoustics is big. We have a lot of optical surveys that use any number of cameras. And so I got to experience a lot of that on those boats, and then also sort of around Port Aransas, where the Marine Science Institute is. I did a number of fish collections and also the hydroacoustic surveys of our big ship channel, which is right by our facility that I was, running the boat and the machinery and all that stuff, or the equipment, I should say. So yeah, it was like directly transferable, which was another sort of, I don't know if it was a coincidence. I sort of wanted to work on things that were widely used and applicable to these large-scale resource surveys, but it was definitely very happy that it all ended up being transferable to the job I have now. I think what is really kind of across any sort of position in this field, the field of fishery independent surveys or standardized field data collections. And you could even extend this to the stock assessments that I talked about earlier, running sort of mathematical projections of how fish populations or other populations of other organisms are doing. I think two things stand out, and that's having the two things are communication skills and quantitative skills. And if you have both of them, there's pretty much nothing you can't do. There's some people who have one or the other, which is great and is not necessarily like a terrible thing if you're super quantitative but you can't communicate well, or if you're a great communicator but you know math is a challenge, there's definitely, you can still do well. But if you have both of those things, that's going to be a real game changer. And it's something that not a lot of people have, I think. There's certainly many examples of great people who've had one or the other. But if you have both, and you can demonstrate that on an interview or something like that, pretty much whatever the role is within this domain, you're going to be pretty competitive. Yeah, I think it's I guess I would say that it's really important to follow your interests. I don't know if this goes without saying, but like you're going to be the best that you can be if you're doing something that you like, and you may not like it every day. I'd be surprised, with whatever it is, if you like it every day. But if in general it's interesting to you and you sort of see tangible outcomes, or at least it's engaging, then you're going to be able to sort of harness your full potential, which is going to probably take you pretty far. It's super difficult to put your whole soul and effort and whatever into something that you just don't really like that much, or something that you feel like you should be doing, but you don't really see the benefit to doing it. It's obviously you can't just like mess around all day and just do things you like in the short term. But hopefully you know what I mean when I'm saying, like, pick something that's interesting, and work on that, and probably you're going to end up okay.